Alright, it says that you purchase a car for $40,582 in 2015, and it has a history of depreciating at 12% each year. You want to sell the car for no less than $8,000. When should you sell it? So, there's a couple different ways that you could go about doing this problem. Stolen, you can have a seat back down over here. Now, if you set the equation up, you start with 40,582, 1 minus 0.12 to the t power, and that would be your A of t, which A of t would be equal to 40,582 times 0.88 to the t power. Alright, now, in order to figure out this, and we want to sell it for no less than 8,000, so that's when we want to sell it. We want to figure out the t value that's going to make this work. Now, one thing that you can do is you can set up a t chart where you go 0, 1, 2, 3, 4, etc. down until you find out your answer. That means you just go into your calculator and here's a really cool thing that you can do in the calculator. If you take the graph and you plug in this function into the graph, 40,582 times 0.88 to the x power. Now you graph it, it's not going to be on there at all, because this goes to almost 7, 10, negative 7, 10. Doesn't do anything like that. But if you hit Control T, it gives you, like when t is 0, t is 1, t is 2, t is 3. And we keep going down here. It's somewhere between 12 and 13 years. So you can actually plug it into your calculator, and then if you wanted to figure out a problem like this, you could go and you can, in the graph, type in the function, Control T gives you the table of values. And you can figure out it's going to be somewhere between 12 and 13. Well, the thing is, we don't know what it's going to be. But we know it's going to be between 12 and 13. Another thing in the graph that you can do is want to get rid of the table of values. And I want the graph in there. So I want to hit Window, and I want to hit Zoom Fit, which is A, because then it presumably will put the graph in there. And what value do we want the car to be? 8,000. So go ahead and graph in 8,000, not 80,000. And way down here, the two graphs are going to hit each other. So we're going to have to move the window, so you can go up in space somewhere, hold the middle button until it looks like you grab the graph, and then move the graph until they hit each other. Do they hit each other? Alright, they're going to hit each other somewhere around here. The graph function has a really cool way of doing this. You go to Actions, and you might not have geometry, you might have geometry. But either way, you got to get the points and lines. Go to points and lines, go to intersection points. And then it says, what two graphs am I dealing with? I'm dealing with that graph. I'm dealing with that graph. And it gave me a point here where all I have to do is go and grab it, move move it up here, this x value is what I want, 12.7. So it equals 12.7. That's going to work. So that's if you want to use the graph way of doing it. Because then you can graph the 8,000 after you graph the original function, see where they cross, and you can do a zoom fit in order to make it happen. That's a pretty easy way to do it. Now, if you want to do it kind of more algebraically, say I want that guy to be 8,000. And that's going to be 40,582 times 0.88 to the t. And since t is in the denominator, we're going to have to use that natural log nonsense that we've been using before. Let me zoom it out just a little bit. And I'm going to need a calculator in here. First off, divide by 40,582. I'm not even going to bother doing that because I know I'm going to have to take the natural log of 8,000 divided by 40,582 is equal to, that stuff's divided out, the natural log of 0.88 to the t. Well, that t goes out in front. So this is t times the natural log of 0.88. And that's the natural log of that big old thing. I'm not going to write it again because I just don't really feel like writing it again. Divide this by the natural log of 0.88. Then just go into the calculator. Make sure you type everything in right. Alright, I'm going to get a fraction. And in the top, it's going to be the natural log of that fraction. 8,000 divided by 40,582. Go into the bottom, that's going to be another natural log, so I need a natural log of 0.88. And that should give me my t value, which is 12.7. So by doing the natural log, sorry about the glare. By doing the natural log, you can get your t value just the same. The graph works perfectly. The natural log works perfectly. Honestly, I will tell you this. The natural log is the easiest way to do it. But if you're not comfortable yet with the natural log and doing that, use the graph. That one will, that's how it's, the nice thing about it is that's how you do it every single time. The numbers are just going to change. And no matter what the numbers are, if you hit zoom fit on your graph or window fit, it'll get you to what window you need it to be. You don't have to worry about that. I can do 4. Any questions on 2? So there's a couple ways that you can do that. All right, number 4 says the number of birds quadruples every year since 2005. How many years are present today if the population was 86 in 2005? Let's build the function. A of t is going to be equal to, how many birds do we start with? 86. Now, quadruple. What does quadruple mean? Quad is 4. Now, if we doubled it, what would we have for our number here? In here. No, if we doubled the population, it would be multiplying it by what number? If we tripled it, we'd multiply it by, if we quadrupled it, we'd multiply it by 4. So you put a 4 in there, and we're going to raise it to t power. Now, that starts in 2005. What year are we in now? 2016. So t is going to be equal to, you subtract those, we get an 11. So a of 11 is 86 times 4 to the 11th power, which I have a feeling is going to be a very big number. Come on. There we go. I found a happy place for the calculator. So it'd be 86 times 4 to the 11th power. So now we're talking about 360710144 123 parentheses 123 360 million birds. 3.607 million birds. Is it birds? Yeah, it's birds. That's a lot of birds. The question was, you have birds, you have 86 birds in 2005, and they quadruple every year. Yep. And so after 11 years, you multiply it by 4, then 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 by 4, and eventually it goes super fast. Yes. 5? Alright. I'll just kind of set it up for you. It says it decreases for 5 years and then increases.
Excuse this interruption. All C block CPC students, once again, all C block CPC students, on dismissal in just about a minute. At 12:37, you will get your stuff and head down to the commons. There is a bus waiting for you. Once again, C block CPC students, on dismissal, please grab your stuff and head down to the commons. There is a bus that will take you over to CPC for the remainder of the day. At this time, we will be dismissing for...
That's how you do it. It decreases first, so we have to take care of the decrease. This is going to be the new value. After 5 years, this will be the new value of the house. Then we go in and we put the new value. Be quiet! There's your new value, and that new value is going to increase. So you got to figure out the new value after 5 years, and then you have to figure out after that.